Now in this video we're going to talk a little bit more about the transformer. So here's another example of a transformer, and you can see on the primary coil here we've got 1, 2, 3, 4 coils. Okay, so 4 coils on the primary. Here's our AC voltage, which is creating an electric current that's constantly changing direction through this coil here. And here's our secondary coil, which has 1, 2, 3, 4 coils on it. Okay, and then this load here, this could be a bulb, or it could be a resistor, or a motor, or whatever, okay? And again, just be aware of this, you have to have AC voltage going in to a transformer, and you get AC voltage and current coming out of the transformer. Transformers do not work with DC voltage. So just to recap, you have an AC voltage here, which creates an alternating current through this coil, which is constantly changing direction. That creates a magnetic field around this coil, which is constantly changing size and direction. That magnetic field then magnetizes the iron core. Now, iron is what we call a magnetically soft material, which means it's easily magnetized and demagnetized. So this coil here, the magnetic field created by this coil, magnetizes the iron core, and that magnetic field is constantly changing direction and size. That magnetic field then is, because it magnetizes the iron core, that magnetic field then is transferred across to the secondary coil, and that means that the secondary coil has a constantly changing magnetic field or magnetic flux passing through it, and that induces a electric current, or a voltage I should say. That changing magnetic field through the secondary coil induces an alternating voltage across this coil, which creates an alternating current because the circuit is complete, and that alternating current flows through this load. Okay. Now it's important to be aware you don't need the iron core. This will work just with 2 coils with no iron core, but it works a lot better. It's a lot more efficient with the iron core, so you'll always see a transformer with an iron core because it's much more efficient. Okay. Now, what we notice here is you've got 4 coils on the primary side of the transformer, 4 coils here, and 4 coils on the secondary side of the transformer. So 4 coils on the input, 4 coils on the output. Now, let's say that the voltage here, this AC voltage here, is 12 volts. What will be the output voltage? Well, provided the transformer is 100% efficient, okay, now transformers are never 100% efficient, but we usually assume that they are unless we're told otherwise. However, it is important to note that transformers can be 90, 92% efficient. They can have efficiencies in the 90% region, between 90 and 100%, because they are very efficient devices. But anyway, let's assume this is 100% efficient. If there's 12 volts going into the primary coil, what voltage do we get coming out of the secondary coil? Well, it will be 12 volts. Why? Because there are 4 coils on the input and 4 coils on the output. And it's the ratio of these coils that determines the output voltage that you get for a certain input voltage. If the input voltage now becomes 15 volts, then the output voltage will be 15 volts. And that's because the ratio of coils here is 1 to 1. Okay? Now, if the ratio of coils changes, let's say that this here now, somehow we change the number of coils on here so that we've got 1, 2, 3, 4, 5, 6. Let's try and get another couple on there. So 1, 2, 3, 4, 5, 6, 7, 8. We've now got 4 coils on the input and 8 on the output. The ratio now is not 1 to 1 anymore, it's 1 to 2. And that means now if we've got 15 volts in, we'll have, what am I doing here? We'll have 30 volts on the output. Okay, now we can look at this. Here's another example. So here's your primary coil. We've got 1, 2, 3, 4 coils, and on the secondary we've got 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. I'm going to sneak another coil on here just to make this easier. if we can sneak another one on there, we'll now say that that's 1, 2, 3, 4, 5, 6, 7, 8. So we've got 4 on the input, 8 on the output. That means now that we've got a ratio here of 4 to 8 or 1 to 2. And that means that if on the primary coil we've got a voltage input of 12 volts, then on the secondary coil we'll have a voltage output here of 24 volts. This is called a step up transformer. Okay, and this only occurs, we are only going to get this exact 1 to 2 ratio if this is 100% efficient. Okay, if it's not 100% efficient, let's say that this thing is 90% efficient, okay, then you'd have to work out what the output voltage would be. Well, the output voltage is going to be 90% of 24. So 10% is 2.4, and therefore your output voltage here would be 24 minus 2.4, which is 21.6 volts. Okay, 21.6 volts, and that's because it's only 90. If it's 90% efficient, this is okay. But if it's 100% efficient, 12 to 24. Okay, this is a step-up transformer.